Now look into this statement. This problem statement says that a disk of mass 2 kg has a radius of 0.4 meters. So this is the disk. This is the disk which has radius r equals to 0.4 meter and its mass m equals to 2 kg. M equals to 2 kg. So first of all, first question is, what is the moment of inertia? So we have to find out moment of inertia. So we have to find out moment of inertia. Moment of inertia I. So here two point. First of all, we have to find out moment of inertia about an axis passing through the center of mass and perpendicular to its plane. So its plane is, this is its plane. This is the plane where our disk is situated, and the perpendicular axis means this is the perpendicular axis. So we have to find out the moment of inertia about this axis. And why I go through this point of axis in the center, because this is a disk, and we know for a disk or for a circular object, its center of mass is lies on the center of its center of that body. So this is our axis. We know if our axis go through the middle, the formula of moment of inertia I equals to half of m r square. So we know the value of m. The m is 2 kg and our r is 0.4 meter. So we'll find out the moment of inertia, which is equals to 0.16 kg meter square. So this is our moment of inertia about an axis passing through the center of mass and perpendicular to its plane. The second part is about we have to find out the moment of inertia about an axis passing through its edge and perpendicular to its plane. Passing through its edge. Suppose this is the edge. This is one edge. We have to find out a axis passing through this edge and perpendicular to this plane. Perpendicular to this plane. So we have to find out the moment of inertia of that for this axis. So we have to use a theorem called parallel axis theorem. We have to use the theorem which is known as parallel axis theorem. So what is this theorem says? This theorem says the moment of inertia about an axis is equals to the summation of moment of inertia passing through the center of mass of this axis and the horizon and the mass and the distance between this axis and this of that axis and the of that axis and the parallel axis going through the center of mass. So this is the formula of parallel axis theorem. So according to parallel axis theorem, for the parallel axis theorem, I equals to, as this is the this axis go through the center, so we represent this axis as I of c. So this is our I of c means center of inertia of force about an axis going through center of mass. So parallel axis theorem says that the moment of inertia about an axis is equal to the summation of moment of inertia of the axis going through parallel to the axis and going through the center of mass. So this is the axis. This is the moment of inertia axis of center of mass plus plus mass into plus mass into the distance between these two parallel axes, and the distance between these two parallel axes are equals to r. So the distance between these parallel two axes is square. So we can write this as mr square. We know the value of this I of c, which is equals to 0.16, and value of m is 2 kg and r is 0.4 meter. So which is equals to the 0.48 kg per meter square. So this is the answer of our second question. So we understand the problem and solve this equation, solve the problem. Now coming to our next problem, which is said that a solid cylinder of mass 25 kg rotates about its axis with an angular speed of 150 radian per second. The radius of the cylinder is 0.25 meter. What is the rotational kinetic energy of the cylinder? What is the magnitude of the angular momentum of the cylinder? So there are two parts. First of all, we have to find out what is the rotational kinetic energy. So for solving the rotational kinetic energy, we know the kinetic energy I of k equals to half of I, E of k equals to half of I omega square. So we are given the value of omega, which is equals to 150 radian per second. 150 radian per second. So we have to find out, first of all, we have to find out the value of I. What will be the value of I? Here we can see that our a solid cylinder of mass 25 kg rotates about an axis with an angular speed of 150 radian per second. So this is our solid cylinder, suppose, and as there is no mention of at which part this cylinder is rotated, so we can think that the cylinder is rotated, the axis going through its center. So this is our cylinder rotating. Okay, so at that case, when the cylinder is rotating and its axis is going through its center, then we know the formula is half of m r square. So we know the value of m, as this is mentioned that the value of m is 25 kg. So it is 25 kg, and the value of r is 0.25 meter. So it is 0.25 square, which is equals to 0.78 kg, 0.78 kg meter square. So we find out the value of I, we know the value of omega, so we can find out the value of kinetic energy I, which is equals to half into 0.78 into 150 square, which is equals to the 8775 joule. 8775 joule. So we solve the first part of this question. First part. Now coming to the second part, and the second part says that what is the magnitude of the angular momentum of the cylinder? We have to find out the angular momentum. We know the value of, we know the formula of angular momentum. L is R cross P, which is means that radius vector cross with linear momentum, which is equals to the angular momentum L. So if we, from this, there is also another equation which is equals to the, which is the relation between angular momentum and angular velocity, which is equals to the I omega. So we know the value of I and omega. We know the value of I is 0.78 and the value of omega is 150, which is equals to the 117 kg meter square per second. So this is the value of angular momentum and this is the value of kinetic energy. Hope you understand this problem. We will solve two more problem about of this chapter, for this chapter. So Stay tuned with us. Do subscribe to our channel. Thank you.